Welcome to Ganitika.com. This is the website for mathematics lovers, learners and leaders. In this video, I'm going to give you the solutions for the questions on angles of elevation and depression, which can be seen in the website Ganitika.com under the topic Trigonometry Part 3. In this topic, Unit 3 has angles of elevations and depressions, and under this topic, I have given you some questions. So visit this website Ganitika.com, register into this website, and you can answer these questions before you watch this video, and then for the solutions, watch this video and check your answers. The first question given in this website under this topic is, from a point on the ground 25 meters away from the foot of a flagpole, the angle of elevation to the top of the flagpole is 40 degrees. Find the height of the pole. So let's draw the diagram here. You have a ground and there is a point A on the ground and there is a flagpole standing vertically above the ground. Therefore, you have a 90-degree triangle here. And at the point A, the angle of elevation to the top of the flagpole is 40 degrees. So the 40 degrees comes at this place where you have A. And the distance 25 meters is on the ground from A to the foot of the flagpole, and H is the height of the flagpole which is to be found. Now looking at the diagram, we see that there is a right angle triangle and opposite to 40 degrees is H and adjacent to 40 degrees is 25. Therefore you can use tan rule. Tan 40 degrees is equal to H over 25. Rearranging H and finding 25 times tan 40 degrees using your calculator, you will get H to be approximately equal to 21 meters. So this is a very simple question. Just you need to find the diagram and understand that flagpole is vertically above the ground. Therefore, you have a 90 degrees between the flagpole and the ground. The second question given in the website is, from a point on the ground, the angle of elevation of the top of a 15-meter tall building is 30 degrees. So let's understand this. We have a point A on the ground. So we have a ground here. There is a point A. And from this point you are looking at a building which is 15 meters tall and the angle of elevation to this top is 30 degrees. Therefore, this is the diagram for the first line. The flagpole is placed at the top of the building. So we are going to consider a flagpole above the building here like this at the angle of elevation, and the angle of elevation of the top of the flagpole from A is 35 degrees. So from A to the top of the flagpole, the angle of elevation is 35 degrees and the diagram comes like this. Now we need to find the height of the flagpole, which is here, and the distance of the building from the point A. So this is here. So you need to find H and X. And finally, you need to give your answers in 3 significant figures. Don't forget this. Let's make a proper mathematical diagram taking away the pictures of the flagpole and the building. Now we have a vertical line like this above the ground. So it makes right angle triangle with the ground line which is dark green. Therefore we have A as a point here and we can mark the points as B, D, C like this. So we have 2 right angle triangles A, B, D and A, B, C. So we can use both of them to solve for H and X. So first let's use the triangle ABD. From the triangle ABD, tan 30 degrees is equal to 15 over X because 15 is opposite to 30 and X is adjacent to 30. Therefore, we use tan. Tan 30 degrees is equal to 15 over X and therefore X is equal to 15 square root of 3. You can give the answer to 3 significant figures using your calculator. Leave this as 15 root 3 for further calculation so that you will get most accurate answer. So let's go further to use the triangle ABC. This is also 90 degrees at B. Therefore, triangle ABC is 35 degrees and opposite to 35 degrees is H plus 15 and adjacent to 35 degrees is X. Therefore, H plus 15 over 15 root 3. The X value you just found out in the previous section. So, rearranging for H is equal to 15 root 3 tan 35 degrees minus 15 using your calculator. You can find this as approximately equal to 3.19 meters. To 3 significant figures. So it's better to use 15 root 3 from the previous section as it is so that you get an more accurate answer. So this is the solution for question 2. Let's proceed to question 3 in the website. From the top of a tall tower, the angles of depression of the top and bottom of a 10-meter tall building are 40 degrees and 60 degrees respectively. So you are standing on top of a tall tower and you are looking at another building which is 10 meters high, and we do not know how far it is. So the building is 10 meters high here. We do not know the height of the tower yet, but we know that the angle of depression to the foot of the 10-meter tall building and the top of the 10-meter tall building is 40 degrees and 60 degrees. Therefore, for angle of depressions, you need the horizontal from the line where you are, from the point where you are looking into. So we are actually standing on the top of the tower. Therefore, the horizontal line comes from the top of the tower. So from this horizontal line, you will mark the angles of depression like this, 40 degrees and 60 degrees. So these are the angles of depressions to the top of the building and to the bottom of the 10-meter tall building. Now we can make the triangles as a mathematical diagram, and taking away the pictures of the tower and the building, we have the vertical lines like this, and we can make some right angle triangles by joining these 2 points E and C. So we have some right angle triangles here. DC and is perpendicular to EC and DB is perpendicular to AB. Therefore, we have some right angle triangles. And what do we have here? The 40 degrees and 60 degrees are on the top of the diagram. So in order to bring them into the triangles, we use the Z rule on parallel lines. So because of this Z rule, this angle is 60 degrees. And because of this Z rule on parallel lines, this angle is 40 degrees. Therefore, we have a typical diagram for our solution. So considering the rectangle ABCE, we have BC is also equal to 10 meters. The height of the tower is h meters. We can have this as h minus 10 meters, and we can make this as x units, the distance between the tower and the building as x units, and we need to find h and x in this case. Now considering the triangle ABD, we have tan 60 as h. H is dB over x, x is AB. So dB over AB is tan 60. Therefore, h over x is tan 60, which gives you h as x root 3. This is equation 1 for h. Now take the triangle DEC, another right angle triangle. Obviously, tan 40 degrees is equal to DC over EC. DC is h minus 10 and EC is same as AB. Therefore, EC is x. Therefore, tan 40 is equal to h minus 10 over x. Rearranging for h, you get h is equal to x tan 40 plus 10. So equating both the h's together, you get this, and making x the subject and solving for x, you get x to be approximately equal to 11.2 meters. Now finding h by substituting x into one of the h equations. So for example, x root 3, which is simpler than the second equation. So substituting the x value into x root 3, we get h to be approximately equal to 19.4 meters, which means the tower is 19.4 meters tall, and the distance between the tower and the building is 11.2 meters. So this is the solution for question 3. Let's proceed further for question 4. Two buildings of equal height are standing opposite to each other on either side of a road 100 meters wide. So the road is 100 meters wide, and there are buildings on either side of the road which is of same height. So two buildings of same height on either side of the road, which is 100 meters width, from a point between them on the road. So let's mark the point between them on the road. Be careful not to mark this point P in between, exactly in between A and B, like exactly in the middle of A and B. Don't mark it in the middle of A and B. Mark it on either side of A or B, closer to A or closer to B, so that you will have a more appropriate diagram. So the angle of elevation of the top of the buildings are 75 degrees and 35 degrees. So from the point P to the top of the buildings, you will get 75 degrees on one side and 35 degrees on the other side. We have to find the height of the buildings because they are going to be the same. So we have to find the height of the building. The building's height is here. If we mark this as C and D here, and we mark this building's height as H, we also need to find the distance of the point from the building. So we need to find AP and PB. So let's call AP as X. Therefore, PB should be 100 minus X. So we have all the information on the diagram now. We can proceed to find the values of H and X as before. So since we have two right angle triangle, there are right angles at A and right angle at B. Therefore, there are two right angle triangle APC and PBD. So from the first right angle triangle APC, we have relation between h and x like this, as we did before. So h is equal to x tan 75 degrees. Keep it as it is. Let's proceed to the next triangle PBD. Tan 35 is h over 100 minus x. PB is 100 minus x. Therefore, h will be 100 minus x times tan 35. Don't simplify tan 75 and tan 35 at this stage, because we will be using this in further calculation. So you will get more accurate answer if you use it as tan 75 instead of simplifying this into decimal points, into decimal numbers. So now equating both the h equations, we get x to be equal to approximately equal to 15.8 meters, and substituting this x value in one of the h equations, we get h to be equal to 59 meters, which means the height of the buildings is 59 meters and the distance of the point from the building A is 15.8 meters. Eventually you can find the distance of B from the point P by subtracting 100 minus 15.8. So we will have 15.8, 59 and 100 minus 15.8 as the answers for this question. I hope you enjoyed this video and you enjoyed reading the contents in Ganitika.com. Thanks for watching. See you soon in the next video. Bye bye.